different. Okay. So as you can see, based on what I told you, Simpson 3/8 rule, it's a equal to 3h over 8 times fx naught plus 3fx1 plus 3fx2 plus fx3. That is the basic formula for Simpson 3/8 rule with single segment. For the second segment, you will start with x3, x4, x5, x6. So you can see the formula is the same as the first part. The only thing different is instead of saying x0, x1, x2, x3 for the first segment, for the second segment you use the same formula, but instead of x0 you say x3, instead of x1 you say x4, and x2 now become x5, x3, now x6. So in other words, for the first segment, the lower bound is x0, the upper bound is x3 for the first segment. For the second segment, the lower bound is x3 and the upper bound is x6. Okay? If you want to write out for one more time, the next formula will be plus f of x6 plus 3f x7 plus 3f of x8 plus f of x9. Okay, that will be the next one, which in general can be expressed as indicated in this portion right there, in showing the black color. Now, so that means you just apply for each segment Simpson 3/8 rule. Notice one thing: this fx3 is repeated twice, and then this f of evaluated at x6 is also evaluated twice, and that's why you can see in the next equation what I show you is 3h over 8, which is the same thing like the previous equation. Fx naught is shown here, 3fx1 that is shown in here, but then you also have 3fx2, and then these two, when you combine these two, you get something like 2fx3. So in general, that term is here. Okay, and then the last term you have will be fxn, that is shown in here. So let's take a look one more time at equation 17, which is the multiple segment of Simpson 3/8 rule. In this equation, suppose you say n equal to 9 segment. What does that mean? That means this small n here is equal to 9, this n here equal to 9, replaced by 9, and equal here by 9. Okay, and then let's see after that, what does that mean? 9 minus 2 is equal to 7. 9 minus 1, this is equal to 8. 9 minus 3, this is equal to 6. So now, as you can see, for the first summation, I go from 1, 4, 7, blah 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 blah, up to n minus 2, which is equal to 7 in this case. So that means here you will have like 3f evaluated at x1 plus f evaluated at x4 plus f evaluated at x7. Well, those terms are right here: 3fx1, 3fx4, and plus 3fx7. You can see that. Now take a look at the third summation. Here you will have I go from 3 6, 9, 12, blah 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 blah, up to n minus 3. But n minus 3 in this case is equal to 6. So this summation basically means 2 times the summation of f evaluate at x3 plus f evaluate at x6, and that will be it. So here you have 3 times fx3, 3 times fx3, 3 times, where is that term? 3 times fx3. Oh, see, you have 2 times fx3, 2 times fx3. That term is right here. You see that? And you also have 2 times fx4, 2 times fx4. That will be up here in, no, this would be 2 times fx3 plus fx6. See, because the increment go from 3, 6, 9. So 2fx3 and 2fx6. This is 2fx3, and this term fx3 combined with this term fx6 together will give you 2fx6. So clearly you can see equation 17 give you a general formula to calculate multiple Simpson 3/8 rule. One more last remark. If you let n equal to 3, then you substitute into equation 17, then the multiple Simpson 3/8 rule will become a simple single segment rule. Okay? So let me provide you another example, number 2, to figure out the multiple segment Simpson 3/8 rule. Let's say we have the same objective. I want to integrate between a equal to 8 and b equal to 30, the limit of integration of the same function that we did earlier. This is f of x. This is the function f of x given to you. But this time we want to use Simpson 3/8 rule with the multiple segment n equal to 6. Okay? Now, n equal to 6. What does that mean? As you can see from the next picture, what we want to do for n equal to 6 is basically is like this. Here, the horizontal axis is x, vertical axis is f of x. The function, let's say, is given to you here between, this is a equal to 8. The upper limit b is equal to 30. Now, when you use Simpson 3/8 rule with multiple segment n equal to 6, what it means is that you have 6 small segments like this, like that. Okay, so this then again is x naught, which is the same thing as a. This one here is x1. This one here is x2. This one here is x3. And I use a different color. This one right here is x4. This location here is x5. This location here is x6, which is equal to b, or 30. So for this case, what you should do according to Simpson multiple segment is that let us try to integrate just for the first segment, single segment, like that, which means the lower bound for the first segment is x naught, which is equal to a equal to 8. The upper bound for the first segment is equal to x3. And then for the second segment, which I indicate by a green color here, the lower bound will be x3 and the upper bound will be x6. Okay, so the first thing we calculate will be h equal to B, which is 30, minus A is 8, divided by N equal to 6 segment. So immediately you can figure out H equal to 3.66. And that distance H is right here. That is H. Okay? Which is the same thing for the other one as well. Equal segment. The next thing we want to calculate is x0, x1, x2, all the way up to x6. And the corresponding function value f at x0, f at x1, f at x2, all the way to f of x6. Now, obviously, x0, as you can see from the graph I showed you there, is equal to 8. So x1 is equal to x0 plus h, which turned out to be 11.66. Okay, because 8 plus 3.66 is 11.66. And the function at x0 is equal to 177. We can calculate easy by substituting the value of x equal to 8 in the function given to you. And similarly, function at x1 is equal to 270. Alright? So now, after you calculate x0 up to x6 and f at x0 up to f6, we calculate everything, you see. x4 equal to 22.66. The function evaluate x4 is equal to 608. x5 equal to 26. The function at x5 is equal to 746. x6 is equal to b. You can see that 30 is b. F of x6 equal to 901. So after calculating all those things, we apply the Simpson multiple segment. Now, as you can see, the general formula we apply, but in this case you have to be careful because we have 6 segments. That means n equal to 6. Okay, n equal to 6, n equal to 6 segment. If you look at the second term,